we're going to be looking at particle physics. We know that the building blocks of matter are atoms, and the word atom means cannot be cut. But actually, you can cut atoms into protons and neutrons, which make up the nucleus, and it's orbited by electrons. And again, protons and neutrons can actually be cut up, divided into quarks, and electrons are leptons. Quarks and leptons are believed to be fundamental particles. So fundamental particles are particles that cannot be broken down into smaller particles, whereas non-fundamental particles can. All particles have antiparticles, and these particles have the same mass as its particle, but they have opposite charges, baryon number, and strangeness. So leptons are fundamental particles, and the electron family are leptons. So the electron family is made up of the electron and its antiparticle, the positron, which is a positively charged electron. Also, you have the electron neutrino and its antiparticle, the electron antineutrino. Hadrons are non-fundamental particles because they can be broken down into quarks. Mesons are hadrons, and they are particles which consist of 2 quarks. Baryons are also hadrons, but they consist of 3 quarks. And examples of baryons would be the neutron and its antiparticle, the antineutron, as well as protons and its antiparticle, the antiproton. So baryons, for example, neutrons and protons, have a baryon number that equals 1. Antibaryons, for example, the antineutron and the antiproton, have a baryon number of -1. So quarks are believed to be fundamental particles, and the quarks you need to know about are the up quark, the down quark, and the strange quark. And you need to know their charge in terms of the elementary charge E, baryon number, and strangeness. And you can see for the baryon number, it's equal to 1/3, because remember, 3 quarks make 1 baryon. And their respective antiquarks, that is the anti-up, the anti-down, and the anti-strange, will have opposite charge, baryon number, and strangeness, but the same mass as its quark. There are 6 quarks in total, so the other 3 quarks are top, bottom, and charm, and they have their respective antiquarks: anti-top, anti-bottom, and anti-charm. For any reaction to occur, the charge, baryon number, and strangeness must be conserved. So, for example, is it possible for a neutron and a proton to react to produce an electron and an anti-neutrino? Well, if we look at charge, see if it's conserved. Charge of a neutron is 0, proton is +1, the electron is -1, and the antineutrino is 0. So you can see 1 equals -1 is not true, so the charge is not conserved in this reaction, so this reaction is not possible. If we also look at the baryon number. Neutrons and protons are baryon, so have a baryon number of 1 each. The electron and the antineutrino are leptons, so they're not baryons, so their baryon numbers are 0. So again, you can see the baryon number is not conserved for this reaction. If we look at the strangeness, neutrons and protons have 0 strangeness, but also leptons have 0 strangeness. So strangeness is conserved, but because charge and baryon number is not conserved, this reaction cannot take place. The quark structure of protons is up, up, down, and you can see why in that it up, up, down will give you a total charge of 1 for a proton, gives you the baryon number of 1 for a proton, and a strangeness of 0. And the quark structure of the antiproton is anti-up, anti-up, anti-down, to give the opposite charge, baryon number, and strangeness to that of the proton. The quark structure of a neutron is up, down, down, because this combination of quarks will give you an overall charge of 0 for the neutron, a baryon number of 1, and a strangeness of 0. The anti-neutron has a quark structure of anti-up, anti-down, anti-down, and again to give the opposite charge, baryon number, and strangeness to that of the neutron. There is a weak interaction between quarks that is responsible for beta decay. So during beta minus decay, we know a neutron transforms into a proton plus an electron, which is our beta minus particle, and an antineutrino. So in terms of quark structure, we know then an up, down, down quark structure of the neutron is changing into an up, up, down quark structure for the proton. So that means a down quark has changed into an up quark during beta minus decay. For beta positive decay, a proton changes into a neutron plus a positron, which is our beta positive particle, and a neutrino. So in terms of quark structures, an up, up, down quark structure of the proton changes into an up, down, down quark structure for that of a neutron. So we have an up quark changing into a down quark during beta positive decay.